All right, thank you so much for opening your workbooks, page 79. So page 79, there's a big, huge picture. Do you see it? Now, if you look at the board, I've got a colored version of the picture. Now, by raise of hand, how many of you have seen the most recent movie, Gulliver's Travels, starring Jack Black? How many of you seen it? All right, I've never seen it. Put your arms down, put your arms down. But if you haven't seen it, let me tell you about this story, and it's described in this paragraph, and then we're going to box stuff, underline stuff that we're going to use. So, Gulliver's Travels, it's about this guy who gets shipwrecked on an island. But when he gets to the island, there's like these teeny tiny people. He's like a giant compared to these people. So they tie him up. I mean, it's in the picture, right? So what ends up happening is the tailor. Do you guys know what a tailor is? Yeah. This guy that makes clothes, right? Yeah. Girl that makes clothes. So the tailor wanted to make Gulliver new clothes, but he was used to making little bitty clothes. So now they've got this giant, and he's got to make giant clothes, and he didn't really know how to do it. And obviously, like if we had tackled the giant and tied him up, guys, would we have a ruler that was as long as our giant that we tackled? Oh, we wouldn't, right? So we'd have to come up with ways to measure him. So this is how the tailor he was like, all right, I'm going to estimate it. And this is how he decided to measure the giant and then make his clothes. So get ready to draw a box. Let's draw a box first. So first, what this tailor did was he thought, well, I'm going to start with, right here, put a box around it, the distance around Gulliver's thumb. Find it in the paragraph, put a box around it. We need that. We're going to use it in a little bit. Okay, now look at your thumbs. Distance around it. I've got big knuckles. Mine's kind of big. All right. So what about the distance around Gulliver's thumb? Well, the tailor said, all right, I'm going to estimate, underline this part, and he's going to say 2 times, twice around the thumb is going to equal once around the wrist. All right, so let's pretend like we're this tailor's giant. Look at your thumb. If you measure around it, we're going to do it twice, right? So 2 of my thumbs, 1 of my wrist. I'd say it's pretty close. Is yours close? So around my thumb twice. Once. I'd say it's pretty close. How many of you agree? At least it's close. It's an estimate, right? Okay, let's see what the tailor did next. Get ready to draw another box. Okay, so he said, all right, so there's the wrist. Then he's going to say twice around the wrist is once around the neck. Okay, so let's think about that one. So look at your wrist. I like to put them together like this, and I think, all right, 2 of my wrists, is that my neck? Oh, no. Maybe close. I need a mirror. I have to look at my neck in a mirror. Maybe? How many think, oh, it's close? Maybe. Okay. Get ready, let's underline the last one. Let's just flip-flop. So the last one he said, all right, from there, if you go twice around the neck, let's think that's once around the waist. I have no idea. Twice around my neck, 2 of my waist, maybe. I don't know. Interesting. You could go home and measure it with your mom's measuring tape, right? Maybe we should have an activity where we do that. Okay, now at the bottom of your workbook, page 79, you have a table to fill out. Now, on my lesson, I didn't have room to do the table because the picture was too small and then not as cool. So you're going to have to help me. So let's fill out the table. First off, I need a hand in the air. Will you remind me what the tailor did to go from the thumb to the wrist? We underlined it or we boxed it. Raise your hand, help me out. Jovian, what did he do?
Twice around the thumb, once around the wrist.
Twice around the thumb, once around the wrist. Guys, on your table right above it, let's write it in math terms. She said twice around the thumb equals once around the wrist. Do you think that's an okay equation? 2 thumbs equals 1 wrist. Okay, and then let's make sure that they filled out this part of the table right. So take your thumb, times it by 2. So if your thumb was nothing, what's 2 times 0? 0. And then what's 1 times 2? 2 times 2? 3 times 2? 4 times 2? 5 times 2? Okay, so this part of the table done for us. Do you agree? We agree they did it fine. No, let's add it in. Let's remind ourselves what they did. Just put a little times by 2 right here. This actually leads right into what we're talking about today, direct variation. Guys, direct variation, you always multiply. What do we always do?
Multiply.
Wait, did they multiply? Yeah. So this is direct variation. Let's see the next one. I need a hand in the air. Will you help me remember, how did the tailor go from the wrist to the neck? Joey, what did he do?
He times it by 2.
Times it by 2. So if we're writing an equation, would it be 2 wrists equals 1 neck? Like that? put it on your table, make sure you write the math version of what the tailor did, and then let's fill in our table. So don't we just take the wrist and times it by 2 again? Yeah, so let's write times by 2 all the way down. Because we just have to double the wrist to get to the neck. Alright, shout it out. What's 0 times 2?
0.
2 times 2?
4.
4 times 2?
8.
6 times 2?
12.
8 times 2?
16.
10 times 2. Okay, we going too fast? You got this? Stay with me. Okay, next, again, I need a hand in the air. Wait, stop! I noticed something when I was creating this lesson. Guys, look, what variable did we use for wrist? But waist. Do we want to use W again? No, because that would be confusing. Which one is it wrist, which one is it waist? So let's use X. X. Alright, so raise your hand and help me. What did the tailor do for the waist going from the neck? Lauren, what did he do?
Twice around the neck.
Okay, she said twice around the neck was once around the waist. So there's my math equation for it. Oh, convenient. What are we timesing by again?
2.
Alright, fill it in. So we're going to times by 2 right here, and right here,
0,
and right
8,
here,
16,
and right here.
24, 32, 40.
Okay, write it in. Are you ready to race? Make sure you put the inches in. Ready? Set, go.
Done.
0 inches, 8 inches, 16 inches, 24 inches, 32 inches.
Done.
Oh man, you beat me. 40 inches.
No, oh my god.
So, again, direct variation is always multiplying. Guys, did we multiply from thumb to wrist? So is that a direct variation? Did we multiply from wrist to neck? Is that a direct variation? Did we multiply from neck to waist? Is that a direct variation? Okay, there's a little bit more to this. So, flip the page. We're now on page 80. Okay, page 80, there's a lot going on this one. So I'm going to give you a head start. I actually typed some stuff in your lesson first. What I want you to copy down first are these points that I'm circling in red. Put it in your notebooks. Ready, set, go. Again, after you write them down, then you need to graph them on your graph. So we've got our graph. Now a lot of you noticed it goes in a straight line, yes? Let me tell you more things about direct variation. The first thing I'll tell you is it's always got to be multiplying. Not just, remember we said it like a million times. Second thing, when you graph it, it always has to go through the origin. Because the origin is right here. It's the point 0, 0. So does this go through the origin? It does. The next thing, it always has to be a straight line. Because if we connected our dots, would this be a straight line? Yes. So hold up 3 fingers and wiggle them. 1 finger, always check for multiplying. Second finger, always check to make sure it goes through the origin if you have a picture, 0, 0. Third thing, make sure it's always a straight line. Okay? All right, last thing, let's make a table of this information. You ready? So make this table really quick. Find a blank spot on this page. Copy down the table. You need 6 slots because there's 6 points. Ready, set, go. Okay, here we go. In our table, back to our points. 0, 0, x-axis always comes first, and then y-axis. So that first 0 is an x, and the second 0 is a y. Now the next point, 1, 2, is the one an x or a y?
X.
Yes, it is, and then a y, right? Same thing the whole way through. X always comes first, and then y. So when we're filling out our table, take this point and put it right here. So x first, 0, then y. That's the point 0, 0. And then we would put the point 1, 2. So take this point and put it right here. 1, 2. And then what's the next point, guys? Perfect. 2, 4. Then what? What is it?
3, 6.
Okay, hold wait for me to write it. Okay, now what?
4, 8.
Okay, and then what's last?
5, 10.
5, 10. Okay, let me show you another way to figure out if it's a direct variation. What if you don't have a picture? So you can't check the origin, and you can't check that it's a straight line, and you just have a table, and you don't have time to graph it. You should be able to look at it and see if it's multiplying. Okay, here we go. How do we go from 1 to 2 multiplying? Yeah, I agree. How do you go from 2 to 4? 3 to 6? 4 to 8? Okay, and then I always go back to 0. We can times by 2 and still get 0. Okay, so check. Direct variation, is it multiplying every time? Sure is. Okay, I have a question for you. So that problem, it was times by 2 every time. What if we had an example where it was like times by 2, times by 3, times by 8, times by 11? Do you think that would be direct variation?
No.
No, it's got to be times by the same thing every time. Okay, this next part is not in your book. So what I want you to do is put your pens and pencils in your books and close them. Keep your spot with your pen or pencil and just watch. Okay, here we go. Next, here we go. We've got a graph. Does it pass? Okay, can we check the multiplying? No, because we just have a graph. So let's skip the multiplying test, the first test. Second test, it has to go through the origin 0, 0. Does it pass? Sure does, because look, that line is going through 0, 0. So it passes the origin test. All right, second test. Is it a straight line? It is. So it passes the second test. It's a straight line. And then right here, if you look at this, y equals 2x. Because what's going on with the 2 and the x? They're timesing, so the equation gives it away that they're timesing. So do you think this is yes, a direct variation, or no, not a direct variation? Yes. Okay, let me show you more examples. Okay, this one. Let's look at the table first. Looking at the table, how do you times and go from 1 to negative 2? Can I get a hand in the air on this one? How do you go from 1 to negative 2 by timesing? Jake, what would you do? Times it by negative 2? All right, so this one would have to be times by negative 2, right? So what's 2 times negative 2? Is it 0? 2 times negative 2?
No.
Whoa, so that's wrong, right? I would say stop here. Is this yes direct variation or no not direct variation?
No.
Okay, just looking at the table, we know it's no, but let's double check the graph. Okay, the graph, is it a straight line? Sure is, but does it go through the origin?
No.
Nope. So this is where we get sad. Sorry. Nope, not a direct variation. So the table supports it, graph supports it, not a direct variation. Okay, let's look at letter B. Right here, how do you go from 2 to 2 by multiplying? Charles, thanks for raising your hand. Times by 1. So how do you go from 4 to 4? 6 by 6. So if we go back, is 0 times 1 0? Okay, so far the table, is this yes direct variation or no not direct? Okay, by the table, yes. Let's make sure the graph supports it. Does it pass the first graph test? Does it go through point 0, 0? Yay! It does. And then is it a straight line? Yay! So the graph also supports that this is, yes, a direct variation. How many are like, direct variation, I got this. Does it make sense so far? Yeah? Okay, let's see what's next. Okay, this one. This part might confuse you. What if you don't have a picture and you don't have a table? Okay, listen closely. You want to solve for y every time. What are we solving for? What are we solving for? What are we solving for? Y. All right. And guess what? You have all the background skills to do this. I've already taught you this. It's isolating the variable using the inverse operation. Remember how we said that so often? So right here, if we're trying to get y alone, how do you get rid of plus 1? Perfect. Minus 1 from both sides. Now stop and be very careful. Someone's going to do this and you can't. Are 2x and a minus 1, well, a negative 1, are those like terms? No, they are not. So final answer has to look like this. Y equals 2x minus 1. Now, I told you, the very first thing I told you about direct variation is it has to be multiplying every time. Multiplying every time, but wait. Is this part of it multiplying?
No.
So is this yes direct variation or no not a direct variation? Nope. No. Okay, let's do letter B together. Again, just watch. I need a hand in here. What's going on right now without doing anything between the 1/2 and the y? That tells you how to solve it. Sarah, what's going on? They're multiplying. Don, you still with us? They're multiplying. Guys, shout it out. How do you get rid of a multiply? So let's divide by 1/2. Divide by 1/2. Stop. There's an invisible number in front of the x that we don't ever write. I want a hand in the air. Do you remember? What's that invisible number in front of the x we don't ever write like bad math manners? Hopefully, do you remember? It's a 1. Okay, grab your calculators and type it in. You've got to do 1 divided by 1/2. Okay, hold up your fingers and wiggle them. Answer with your fingers. What is it? I agree, little bunny ears. It's 2. So final answer would look like this. Y equals 2x. Guys, you can shout out this. What's going on with the 2 and the x? Multiplying. So is that yes, direct variation, or no, not direct variation? It's yes. Perfect. Open your notebooks, your workbooks to page 82. Open to page 82, the first 82. Okay, number 1, number 2, number 3. Just look at the table and see if you can multiply to get to the other one. If you can't multiply, then it's no, not direct variation. Okay, number 4 has the same exact directions. Tell whether x and y show direct variation. Explain your reasoning. Showing our work can be explaining our reasoning on this one. So I need a hand in there. We're trying to solve for y. What do we have to get rid of and how do we do it? Thank you for raising your hand. Sarah, what do we do? Perfect. I want to see everybody write this down. Subtract 2 from both sides. So then we'll be left with y equals, stop. Can you take x and subtract 2 from it? Are they like terms? No. So our final answer is, well, before we look at it, x minus 2. Okay, now you should be able to look at that and say yes, direct variation, or no, not direct variation. I want a hand in here. Tell me why you think and why. What do you think, Emily?
No, because it's not multiplying.
Perfect. So right here, if it was my assignment, I would just draw right there. That's the problem, and then I would put no. There we go. I just showed my work. Jake, you got that? Okay, make sure you have every single one of those steps in there. Okay, I kind of want to help you with number 5 because it's going to trick you. Number 5 is misleading. Okay, let me move this over. I know, but watch. I'll help you figure. So number 5, make sure I write this down. Isn't it right? Isn't it 3y equals x? Okay, hand in the air. What's going on right now with that 3 and the y? Corbin, what's going on? They're timesing. So Corbin, what do we do? Perfect. Guys, write this down right now. Everybody should have the divide by 3 on both sides of the equal sign. So now that looks like y equals x over 3, right? And then I told you, well, direct variation, you always multiply, right? And that's showing division. So guess what? You can write that, and it means the same thing, but there's multiplying instead of division. Ugh, it's confusing, but I think once I show you, you'll be like, oh, that is right. Cameron, do you have an idea?
Wait, is this number 5?
Yes, this is number 5. So this is the same thing as, we've got to be able to write this exact same thing a different way using multiplying. So y equals, does anybody have any idea how to change this to make it a multiplication problem? Do you have an idea, Charles? 3 times 1, not quite, because 3's got to stay in the denominator. We can't move the 3 around. Thanks for raising your hand. Joey, do you have an idea? No, we can't change it to a negative. It's got to stay positive. We can't change it. It's got to be the same thing. You got to think, what is that 3 doing? Actually, you know what, Sarah, I want to hear from you before I show you something. Oh my gosh, that's what I was going to show you. Okay, Sarah got you super close. Okay, Cameron, you watching? Chance, you watching? She said y equals 1x over 3. Close. So incredibly close. That can give it away. Are you ready? So if you take out the x, what fraction is in there? So don't you think that we could write this as, take the fraction out and put the x right next to it? Do you think this is the same as this? These are all the same thing? They are. So is that showing multiplication? So this is yes, direct variation, or no, not direct variation?
Yeah.
That one's technically a yes. Told you it was tricky. Here we go. Number 7, keep it as y equals 8, x equals 2. Number 8, let's make it y equals 160, x equals 16. And then number 9, make it y equals 25, and x equals 5. Make sure you make those changes. Easy. Number 7, my hint to you is to draw a table. So put your x's, put your y's, and let's just do 4 slots. 1, 2, 3, 4. Oh, that's 3. 1 more. There we go. So make a table, make it blank, but then take number 7 and put it in your table. So number 7 says when y is 8, so I'm going to put an 8 where the y is, x is 2. Okay, well, remember how we looked at the tables and we thought, how do you go from the x to the y multiplying? Jovian, you watching? Guys, how do you go from the 2 to the 8 and multiply?
That's 4.
Yeah, so right here in the middle, just write times by 4. So what do you have to do with the rest of the table? Just put nice numbers in there. So 1's pretty nice, 0's pretty nice, and I would say 3's pretty nice. So we're timesing by 4 every single time. So what's 0 times 4? I'm out of room. 1 times 4? 3 times 4? Take 7, 8, and 9 that far. I just want to see a table. So same thing, I'll get you started on number 8. So number 7, just finish a table. Number 8, make a table. Let's do 4 boxes. Start with number 8. I gave you when y is 160, x is 16. So you got to figure out how to go from 16 to 160, multiply, and then put nice numbers in there and fill out the rest of the table. And then number 10 is the last problem on your assignment, and the table's already done for you. So look at the table and decide yes or no.